In this class we will discuss a concept of metric related to the route. So in the previous classes we discussed about the concept of administrative distance. So when a router learns about the same network from different routing sources like a static route or dynamic routing or connected route, it will choose the one which has the less administrative distance value. So apart from administrative distance value, metric also is an attribute of route. So metric comes into the picture when a router receives the same route from the same routing protocol, but it is coming from two different devices. So in that case, it will check the metric value to choose the best one. So in this topology, we have two PCs. One is in 10.0.0 network and another one is in the 192.168 network. So in between R1 and R5 we have R2 and R4. So in this topology currently we are enabling OSPF on all the router interfaces, so that R1 will learn about the 192 network in the same way R5 also will learn about the 10 network. So in this topology, let's look at how R1 will know about the 192.168 network. So when R5 running OSPF, it will send LSA with the information of 192 network. So that LSA will be flooded all over the area, so all the routers in this topology in the same area, so that this link state advertisement will reach R1. So now R1 knows that 192.168 network is on R5. So then it will check the path to R5. So currently it has two paths, from R1 to R2 to R5, and another path is R1 to R4 to R5. So in OSPF the metric is cost. So each outgoing interface in the path between the router and the distant network will be calculated by adding the all outgoing interfaces cost. So in this topology all the interfaces have the same cost. So you can verify that using the command show IP OSPF interface brief, and you can see the cost column here. So by default in this topology it has the cost value of 10 for all the interfaces in this network. So this is the advertisement received from 2.2.2. In this case 2.2.2 advertised about it networks. One is 12 network, another link is 25 network. So if you see, the cost is included in the LSA. So let's see the routing table in this case. So when we look at the routing table for 192.168 network, it is selecting two paths because the cost for reaching from R1 to R5 and through R2 and R1 to R5 through R4 is the same cost. Okay, so when the cost is matching means metric is also matching. So in this case the cost is 30. So there are three interfaces involved in each path. So cost of all the interfaces is 10. So for this path cost is 30 and this path cost is 30. So R1 uses both paths. Okay, so that's why in the routing table we have two next hops for this network, because both the routes are coming through OSPF, so that's why both have the same AD value and both have the same metric value. So that's why it is included two next hops as the valid ones. Okay, so in this case some packets will go this way and some packets will go this way. So now if we want to prefer the path through R4, so what we can do is we can change the cost of this particular outgoing interface here. So you can change any of the outgoing interface cost, but in this example I'm just using the R2 outgoing interface. So I have increased the cost of link between R2 and R5 as 20. So this is 10, this is 10, this is 10, this is 10. So now let's see what R2 advertising about its networks and the cost. As you can see, this 25 link, which is between R2 and R5, has the metric of 20 because we manually changed the cost of this one. So OSPF has some formula to calculate the cost based on the bandwidth. So we don't need to go into that details in this class, but cost is something OSPF uses as the metric. So now if we look into the routing table, the cost from R1, R2, R5, this path is 40 and this path is 30. So even though R1 knows it can reach through R2 and R4, now it will only inject one route into the routing table, which is going through the R4. As you can see it in the output, now it is only installing one route. So before configuring this, the cost of all the links are same, so that's why it added next hop as R2 and R4. But once we change the cost of one of the link, now it will have the tiebreaker resolved to the R4 is the best path via R4. So in OSPF, metric is cost. So now in the same topology, we are configuring BGP between R1 and R2 and R1 and R4. So we are using this BGP to send the same information, same routing information. From R2, I will be advertising 192.168 network. From R4 also, I will advertise 192.168 network over eBGP. So once we advertise from here and here, what I am doing is, in BGP we can use MED that we discussed in the previous classes as a metric. So whenever I send routes from R2, I am using the metric of 200. How I am applying that is using a route map. So in this route map, I have applied the metric as 200 for on R2, and this is when advertise it to the neighbor 12.12.1, which is R1 in the outgoing direction. So whatever the routes R2 is advertising, it will advertise with the metric of 200. If you don't put any metric value with the route map, it will take it as 0. So from R4, I am doing the similar route map, but here I am setting the metric of 400. So now R1 will learn about 192.168 network in 4 ways, 4 sources. So one is OSPF, another one is BGP. In OSPF, it is learning from R2 and R4. From BGP also it is learning from R2 and R4. So eBGP has the lesser administrative distance value, so that this will be selected out of these two routing protocol sources. Inside that, both will have the same AD value, so now it will choose the metric to choose the best one. So in this case, R2 has the lowest metric, R4 has the highest metric. Okay, so let's go ahead and check the routing table now. So in the routing table now you can see router preferring the route via R2, because if you can see the metric value here, it is 200. So when we look into the BGP received routes from R2 and R4, if you see the output here in the metric column, all the routes learning from R2 has the metric of 200. All the routes learning from the R4 has metric of 400, because we have applied the route map. with the different values on R2 and R4. So now BGP has chosen the route which has the lowest med, which is metric in general. So assignment for this class is build the similar topology. So you have R1 here, R2 and R3. So we need to do some additional configuration to make this topology work. So one is on R1 I have applied the deny out route map towards R2 and R4. Sorry, this is R4. So why we are applying this is, if we look into the route map, it has a prefix list and we are denying it. What is the prefix list has? It has 192.168 network. Because if we don't apply that, what will happen is when R2 advertises 192 network, R1 will advertise it back to R4. So in this topology, we don't want to advertise 192.168 network from R1. So that's why I am denying 192.168 update towards the R2 and R4. So that's the purpose of this route map. Next, on the R2 we have applied the route map med out, and the configuration is this. Go to the route map and set the metric with the permit statement so that it will apply the metric 200 to all the routes. And then R4 we are doing the same route map med out direction and applying the metric as 400. So in this way what happens is, in this topology, R1 will receive information about 192.168 network from two different routing sources. One is from OSPF, another one is from BGP. So OSPF cost is 110, BGP is 20, eBGP in this case. So which protocol it prefer? Here is the tiebreaker is AD, so it will choose the lowest one, so it will prefer eBGP. So inside eBGP it is learning from R2 and R4. So now AD is same for both the routes. R2 is telling that R2 is telling R1 that you can reach 192.168 network through me, and R4 is also saying the same thing. But the difference here is, when they are advertising the routes, they are advertising with two different metric values, R2 with 200, R4 with 400. Now what router will do is, because AD is same for both the routes, it will next compare the metric value. As the R2 has the lowest metric, it is choosing this one. So this lab is to understand the concept of metric. That's all for this class.